Having mounted the laser diode to the MPCNC as outlined in my previous video, it's now time to find the focal point of the laser and try a few test cuts. There are many ways to find a suitable focal distance, but I will demonstrate a quick and easy method that has worked well for me. I start by lowering the gantry of the MPCNC as close to the spoil board as possible. This will ensure the laser module is out of focus because it is too close to the material. Next, we've got to write some G-code by hand, but don't worry, it's not a very long program. We start out by setting the units in positioning mode and establish the G1 and G0 feed rates. I set my feed rates to 60mm per second, which is a reasonable value for this kind of test. Next, using inline commands, we tell the CNC to drive 50mm on the Y-axis, with the laser operating at full power. Then we move over 2mm on the X-axis and raise the Z height by half a millimeter. We can copy and paste this code, telling the machine to return to Y0 while making the second line. We raise the Z height and repeat until we are certain the laser module will be higher than the correct focal distance. After marking the final line, we can send the machine back to its origin position. Before running the code on the machine, we can check it using a brilliant site called NC Viewer. By copying and pasting the code into the viewer, we see that the machine plots a nice staircase pattern as expected. When using a laser cutter, air assist is very important. Even if you don't have a compressor, a simple computer fan or centrifugal blower will suffice to prevent smoke and cutting debris from building up on the lens of the laser module. Before proceeding, it is imperative to wear laser safety goggles while the machine is powered on. Respiratory protection is also advisable. I insert an SD card loaded with the focus test program into the smart controller and set the program running. It doesn't take long to run and leaves a series of lines burned into the spoil board, which can be examined to determine the usable focal distance. The lines on the far left of the pattern are out of focus, being drawn too close to the spoil board. They become sharper progressing to the right as the laser module moves up. Eventually, the lines once again become blurry as the laser module is too far away from the spoil board. In some cases, it may be necessary to write a longer program and drive the laser even higher. This test shown here is just a demonstration of the methodology. This image shows how to measure the correct laser height by finding the best Z offset. Picking the sharpest line, it is easy to determine what corresponding Z height in the G-code it was drawn at. Driving the axis into position, the laser offset from the workpiece can then be measured using a set of calipers. I conducted a more rigorous test off camera and cut a spacer block to easily set the laser height. To generate useful G-code for the machine, I recommend using a software called Lightburn. If you can afford to build an MPCNC, you can probably afford to purchase a license for Lightburn. Upon installing and opening the software, you will need to configure your machine. In the pop-up dialog, select Create Manually and choose Marlin from the menu. Enter the dimensions of your machine's working area, and continue to click through the dialog. Next, it's important to adjust a few device settings for the MPCNC. Under Edit, Device Settings, make sure to enable Fast Whitespace Scan at about 60mm per second. This will be your G0 feed rate. If you are on a high-resolution display, expand the dialog box to expose the laser control commands and select Inline. Finally, make sure the S value maximum is set to 255. Under the G-code tab, paste in the G-code shown on screen to increase the maximum feed rate of the MPCNC before each program starts. This step is only necessary if you want to exceed the default, very conservative MPCNC maximum feed rates. To generate G-code for a 2D profile, a DXF can be dropped into the Lightburn workspace. I usually place the workpiece near the origin to simplify the physical cutting operations. By default, the DXF will be on layer 0, and its settings can be modified by double-clicking on the layer in the upper right menu. For the material I'm cutting, I use a speed of 5mm per second at 100% power. The laser will make 2 passes to cut through the material. By hitting Alt-P, I generate a preview of the toolpath and verify that it will behave as expected. Clicking Save G-code allows me to save the program to a file and load it onto the CNC via an SD card. With the laser focus sorted, I fill up an old barbecue tank to use for air assist during cutting operations. The tank is a pressure gauge and a regulator, and on 15 psi of air assist output, I can run several shortcuts before needing to refill it. The air assist hose is connected to the tank and the laser module, and the machine is ready to cut. The 1/4-inch plywood is positioned under the diode, and the height is checked with the spacer block to ensure correct focus. Here the laser is cutting through the 1/4-inch plywood in only 2 passes at 5 mm per second and 100% power. Because the plywood was slightly damp, the cut didn't turn out perfect, but it was still a pretty decent result. To find the right settings for a new material, it's convenient to run a Powerscale test. I generate my power scales using this brilliant website on O2 Creative. The power and speed ranges can be adjusted to suitable ranges for the material you are testing on, and for the MPCNC, select My controller only uses max power. Labels can be machined on low power with a relatively high speed. Do not make the rectangles too small, otherwise the test will not be useful due to the MPCNC's low default acceleration values. Ellipses may be a more suitable test shape. For cutting operations, set the layer type to line. It's a good idea to clean up the Powerscale test in Lightburn and check the preview before generating G-code. I ran this Powerscale test on 1/8-inch cardboard from an old Amazon box. There were a few squares which showed promising results. The laser can cut the cardboard in a single pass at 20 mm per second and 90% power. With the correct settings dialed in, it's time to start making some cool stuff. I found this file on a site called 3axis.co and decided to try cutting it out. The laser cutter is a great way to turn scrap materials into cool trinkets for friends, make custom engravings, and it opens up great possibilities when designing and manufacturing parts for engineering applications. I've only just set my machine up, and I'm already helping my friends with loads of different projects. If you found this video helpful, please give it a like, and consider subscribing for more interesting content in the future.